this video is about acceleration. It didn't come up last year in the AQA paper, which makes me think it might come up in some way this year. So acceleration is actually a change in velocity. So if your direction changes or your speed changes, you accelerate because velocity is speed in a given direction. So for example, Earth is actually accelerating around the sun right now, even though we're going at a constant speed. So it is possible to go at a constant speed and still be accelerating. It's measured in meters per second squared. If they ask you to work it out, you will have to put the unit because everybody forgets to put the squared. So it's an easy mark for them sort of to give away. The way you calculate it is it can come up in two different formulas. So the first is relating to force and mass. So acceleration equals force divided by a mass. So if in the question you're given force, or they mention force or weight even, and a mass, then this is the one you should use. It is given like this in the formula sheet. The other one is if they mention velocities and a time. So acceleration equals v minus u over t. Now v is just your final velocity, and you are told that, and u is just your initial velocity. So your starting point for velocity divided by the time it takes, and it's in seconds. Be careful if they tell you it in hours, you do need to convert it. So you use this if you're given two velocities and a time. Now they might only give you one velocity, but they may say from stationary, which means from zero, basically that would be your starting velocity. So I'm going to go through exam questions that have come up in the past. So for example here, it says the diagram shows a horizontal forces acting on a car with a mass of 1,200 kilograms. Calculate the acceleration of the car shown in the instant in the diagram. Write down the equation you use and then show clearly how you work your answer and give a unit. So they're telling you what to do. So I've been told forces here and I've been told a mass. So I'm going to use acceleration equals a force divided by a mass. Now when it comes to my force, I've been given two forces here. You have to work out your resultant force. Now resultant force is the overall force acting on an object. I always like to think of it like a tug of war. If you had 3,500 people pulling you this way and 2,000 people pulling you that way, and they all had equal strength, you're going to go this way with a force of whatever this minus this is. So F, side working out, is 3,500 minus 2,000. I know it's quite easy to do in your head, but it is good to show that you know how you found the number. 1,500 newtons. So that's the F we're working with. And mass is given to you. So acceleration equals 1,500 divided by 1,200. And that equals 1.25 meters per second squared. So you can leave it there, but it's always best to put it where they've asked you to put it. So I'd put it 1.25 meters per second squared. 4 marks. That is a lot of marks, and one of those marks is for this, the meters per second squared. One of the marks is for your answer. One of the marks is for showing you're working, and you get a mark as well for working this out. So it's always best to show everything. Another way they could ask you to work out acceleration would be this, for example. The boat accelerates at a constant rate in a straight line. This causes a velocity, so they're talking about velocity, of a water skier to increase from, that's our initial velocity, to 16, our final velocity, in a time of 8 seconds. Calculate acceleration, just 3 marks this time. So I'm going to use A equals V minus U divided by T. So A equals our final 16 minus 4 divided by 8. We'll just go up here, I've run out of space. So this would be, excuse me, 12 divided by 8. And that gives us a acceleration of 1.5. So you'd put 1.5 meters per second squared. And you see again, they want you to put the unit, and that's what you get a mark for. Mark for the unit, mark for the answer, mark for your working. Now, they've then related this back to resultant force. So you've used one formula here, but they're now saying the water skier has a mass of 68 kilograms. calculate the resultant force acting on the water skier while accelerating. Use the correct equation in the equation formula. Now here, people go, okay, so we found a resultant force and we've got a mass. But if we were using the F and M and A, we haven't got A. You've just worked it out, okay? So you've got to use this. So force equals mass times acceleration. Mass is 68. Acceleration you've just worked out 1.5. So that will equal 102. So 102 newtons, they've given you that already, so you don't get the extra mark. Incidentally, if you hadn't done this correctly, but used it correctly within this answer, even though this would be wrong, you'd still get both of those marks. It's called error carried forward. So even if you don't know this, but you know how to do that, take a guess. They can't penalise you twice for it. I hope that helps.